Hello my dear champions, welcome back to the channel. So I am here with another beautiful session today on the rapid revision of the chapter inverse trigonometric function and relation and function. They are very simple topics, okay, nothing much challenging about them. Maybe some questions in particular might challenge you once in a while, but usually the concepts and the problems are very simple over here. That's why we have to do this as a must, because any questions coming your way from this topic has to be done and taken as bonus, right? So I hope you're ready for the rapid revision of these two chapters. They're small, not many concepts are there, so we're going to complete this very quickly, but we'll cover up all the subtopics, all the concepts in the chapters. We'll not skip even one bit of it. Again, this is all for your revision of your PU2 midterms for mathematics, so this is very much clear. Now before I start the session, I have a surprise for all of you, and that is regarding our 90-day crash course, which will help you cater to examination COMET, K and KCET. And goal is very simple. We are looking to get top 1000 rank in the colleges of Karnataka, get the top colleges of Karnataka. Now, so bacha, the thing is, right now your midterms are here. Half of your year is almost over. Now very soon your syllabus will be covered in the colleges, in their schools, and then you'll move on to pre-boards, boards and practicals, okay? So time will not be there for you to think and plan your work, okay? If you're struggling somewhere, if you're not able to, okay, say clearly that you can get a JEE college, you'll get a top college in NITs or IITs, then one of the safety net for this is going to be your top colleges of Karnataka. They are very good. And how do you get into these colleges? By writing examinations like KCET and COMET K. So it's time to take actions, to take good decisions, and for that we have brought 90 days offline crash course. Yes, it is offline, so you need to call on this number to get to know which is the nearest Diksha campus to your home. Okay, so you have to call on this number to know, because this is being taken at, so last year I think we did only for a few campuses, and then some of you complained that, sir, if we could have this done at nearest of our campus, then we could have taken the course. Okay, so this year we have brought this at various campuses of Diksha, so you need to call on this number and check which is the most suitable campus for you, so that you can attend the classes regularly and do the process right to get the top 1000 rank in your KCET and COMET K. Okay, and you can easily score that, that very well. Syllabus is different over here, exam requirement is different over here. That can be achieved if you are very much thorough, if you are very much disciplined, and that we can help you with our experience for more than 27 years in helping students in all these examinations. So start right now, take the decision, make a call and get to know which is the nearest campus and the structure of this whole 90-day crash course. And don't worry, it is planned in such a way that it caters to your school and your college timetable. Okay, so do not worry about that, just make a call and get to know more details about KC90 crash course offline, made solely to make you get into the top colleges of Karnataka. Okay, so let's move on then with our session. Session is on the two chapters, relation and function and ITF, starting with the relations. Again, very basic, so basic definitions are there. They're very important because questions can be directly asked in MCQs on these definitions. Okay, so first is definition of empty or void relation. What is that? Any relation which has none element in it, means the number of element in that will be 0, basically is called as empty relation. A relation R on a set A is called as empty, or void if it has 0 element or none of the elements are there from any of the set. Okay, so that is a empty or void relation. Next is universal relation, when you have each and every element of the set A is related with every other element of set A. If you are talking about universal relation, a relation R defined on the set A, then every element of set A will be related to every element of set A is called as, that type of relation is called as universal relation. Okay, they're very simple. The two extremes, none, everything. First one means none, second means everything. Identity relation means whenever you have relation to itself, or element is related to itself only, is called as identity relation. Okay, so definitions are given over here. You can download this class notes in PDFs. Where you can get that? WhatsApp channel is there. Link for that is given in this video description. Go ahead, click on the link. will share the drive access. You can go and download all the class notes from there. Okay, so because these are definition based chapter, you have to know the definitions. I've already given you over here. You can take from there, otherwise you can take from NCERT also, not a problem. But if you want to, you can download the class notes from the WhatsApp channel. Now let's talk about types of relations. Types of relation, which is where our questions will come from in the relation category. Reflexive, symmetric and transitive relation. Reflexive, symmetric and transitive relation. So whenever you have a set defined like this, let's say set A is 1, 2, 3, then when can we call a relation R? Reflexive is very simple. If you have the ordered pair, you all know what is ordered pair. We learned in PU1, Cartesian product of the sets A cross B. If we do, we'll get the ordered pair, right? First is the from domain, other is from codomain, right? So 1, 1, in this case we have the relation defined on the set A. So A to A actually is defined like this, A to A. So reflexive will be in the case if it is 1, 1 there, 2, 2 there, 3, 3 there. If it is there, no, if this much element is ordered pairs are there, we call the given relation to be reflexive. Then sir, you said right now something about identity relation to itself only. Isn't this same as this? Something similar but not same, because in the case of identity we must have only this 1, 1, 2, 2 and 3, 3. That is the end of the relation. This has to be the case of example of identity relation defined on the set 1, 2, 3. But in reflexive I can also have 1, 3, 1, 2 or other elements. Means apart from 1, 1, 2, 2, 3, 3, I'm allowed to have other ordered pair also in the case of reflexive relation, whereas in the case of identity relation we must keep only the elements to itself only. In the case of reflexive, itself and other ordered pair can also come. Okay, this is definition of reflexive relation. Moving on to symmetric. Symmetric and transitive deals with the case of if and then. Means you have a if statement and you have a then statement. In case of symmetric, what is if statement? If the ordered pair is A or B, what it means? If A comma B is the ordered pair in the relation, then B or A ordered pair B comma A must be there. If A or B is present in the relation, then B or A has to be present in the relation. That's your symmetric relations definition. In the case of transitive, we have two if statements. We have A or B and we have B or C. We have two if statements. So A or B means what? Ordered pair is AB, and B or C means what? Ordered pair is BC. Then what happens here? Then statement implies like this, A or C actually, not B or C. It has to be A or C. It has to be then A or C, which means AC ordered pair must be present in the relation. So if in the relation we have AB and BC ordered pair present, then AC must be there for it to be a transitive relation. Okay, clear? Same thing written in the definitions also. So please go ahead and download these notes and read from it. Okay, so this is clear on the types of relation and the combination of the three. If you have a relation R which is reflexive, which is symmetric and also transitive, if any given relation is all three at the same time, then what happens is you call that relation to be equivalence relation. You call that to be an equivalence relation. This is for reflexive, this for symmetric, and this is for transitive. So this three condition has to be satisfied at the same time. When that happens, the relation becomes an equivalence relation. Okay, let's move on then. Okay, next up is relation part is over. We'll move on to functions. As I said, the chapter is not big. There are not too many concepts. So yes, but we must know the concept that we have learnt in the chapter in the first part of relation and function in the PU1. That is a must. Okay, but yeah, in the PU2 there's not much topics there. We'll quickly cover it and then complete our session. 1, 1, many 1, on 2, and into. 4 parts are there. We'll figure it out. Okay, so 1, 1 and many 1 functions. Whenever you have, so we have two things in case of functions, right? You know what is functions? It maps uniquely from domain to codomain, right? Any relation which has unique mapping. Okay, so we'll not get into the definitions of functions right now. We have to figure out our work for the 1, 1 function. also called as injective. So check carefully here. If I write the domain and codomain, if I write the domain and codomain, and whenever we have unique and distinct mapping, whenever we have unique mapping from the elements of domain to codomain, okay, whenever have this kind of mapping, then this is called as 1 1 function. Means for one value of x will have only one value in y. So basically if I try to take a graphical approach, there is a function given like this, and you draw a line parallel to x-axis, you will get only one intersection. Now that is called as 1 1 function. That is called as 1 1 function. This is the graphical understanding. This is the from the mapping understanding. But let's say algebra. So if you have two values, let's say x1 and x2, they are both equal in nature. Two values of x equal in nature, then f of x1 should also be equal to, basically start from like this. If f of x1 is equal to f of x2, I have written ulta here, I'll change it. I wrote just opposite what I was supposed to write. If it is f of x1 equals to f of x2, then x1 and x2 has to be equal. And if you have f of x2, if you have x1 and x2 not equal to each other, means if you take 1 and 3, is 1 and 3 equal? No. Then function value at 1 will not be equal to function value at 3. This is the algebraic approach. Do not worry. When I solve your question session, when you come to watch the session on the questions, I'll talk about all this method, graphical, algebraic mapping in detail over here with the help of questions. Right now understand this. We are trying to identify a given function, whether it is 1 1 or not, with the approach which is mapping, algebraic and graphing. For graphing we have unique intersections. Mapping is two cases. If they are equal, then function value will not be, if they are not equal, then function value will not be equal. If the function value is equal, then the value of x will also be equal. Mapping is always unique in nature for 1 1. Otherwise it will be many 1. Any function which is not 1 1 is many 1. Okay, here you will not have distincts. Okay, means if there exist at least two distinct element in A for whose image are same, this is many 1. Many 1. Check this out. For the two different value x1 and x2, we have same value in the case of, for two different values of x, x1 and x2, we have same value in y. Please check. x1 and x2 is here, we have same value in y. So even though x1 and x2 is not equal, we have f of x1 equal to f of x2. In this case, if x1 and x2 are not equal, we don't have f of x1 and f of x2 also not equal. But in this case of many 1, x1 is not equal to x2, but f of x1 is equal to f of x2. This is the many 1 case. Not 1 1 is called as many 1. Moving on to the onto cases. Onto cases, also called as surjective functions. Also called as surjective. Injective was for 1 1, surjective is for onto, and the combination of 1 1 onto becomes bijective. Combination of injective and surjective is bijective. Onto, what is it? So whenever you write your domain, codomain, and you find a range also, right? What is range? Range is the set of all elements of what? Images. Means if you're doing a mapping, right? You'll do a mapping, right? Check this out. If I do a mapping like this, here, 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 I still have some elements left now. Let's say this is 1, 2, 3, 4 is left. So my codomain here is 1, 2, 3, 4, and your range over here is only 1, 2 and 3. So range is the images that you get after the mapping. Okay, after putting the domain values, element of domain in this, in the function, whatever comes out is your range, and the total set is called as codomain. So whenever you have range and codomain equal, whenever you have codomain and range equal, okay, so yeah, when the range of the function and codomain of the function is equal, then you call the function to be onto in nature. If you have range and codomain equal, in this case codomain is not equal to range, check this out, is 1 2 3, 1 2 3 4, then we'll say function f is not onto. This is the function f. Okay, this this mapping is called as function f, is not onto. Not onto means into. A function a to b is called into function if there exists an element in b which is no preimage, which has no preimage, means for 4 we don't have any preimage. This is called as images, and these elements over here, let's call it a, b and c, are called as preimages. So for the element which is given as 4 is not having any preimage, so it is basically left out. If you have something left out means it will be not onto or simply into functions. Please check. Okay, so this is the definition of onto, into. Now combination, if you have 1 onto together, that is called as bijective function. Let a some notes. If a to b, then consider y belongs to b, any arbitrary element. Okay, so this is how to find, basically your range, right? Put y equal to f of x, solve it to obtain x value in the terms of y. For y belongs to b, corresponding value of x does not belong to a, then the f is not onto. Because what happened, no, you are able to find one value in the codomain which has no preimage. If for y belong to b, what it means? For any value in codomain, please be with me. Y belong to b means any value in codomain, corresponding value of x does not belong to a. Means for some value of b, there is no preimage. For some value in the set b, the some value in set b has no preimage, there is no mapping done. For other elements mapping is done, it's available, but this is left out. Then what happens? Then it will be not onto. But if for y belongs to b, corresponding value of x belongs to a, then f is onto. Because what happens, no, if something is missing out means, in this case we'll get codomain and range are not equal. Do not worry, when you come back for the question session, I'll teach you all of this with the help of a problem. This is a rapid revision, so only concepts we are doing over here. I'll repeat myself. If for some value in codomain you are not able to find any any preimage, then what will happen? That function will not be a onto function. This is how to identify. This is the way to find range. This is how you find range. Basically, identify onto functions. Is that clear? Now, a function which is both 1 onto is called as bijective function. Distinct element of a have distinct images in b. This is 1 part, and this is onto. Each element of b is the image of some element in a. So none of them is left out. So 1 onto. The combination is called as bijective. Clear? So this is it. Next is what? Number of functions. Sometimes questions can be asked on this, but usually this is a concept for your KCET, your Comet K. But here I have seen some problems in one of the publications on the HOTS category where the questions on this has been asked. That's why I've taken over here. A to b, if the function is defined, n of a is basically cardinal number of the set A, the domain, and nb represents the cardinal number of the set B, the codomain. Then number of functions is given by n power m. N power m. Okay. Number of one function is given by npm, n permutation m. Okay. Number of onto function is given by -1 power n minus r times of ncr r power m. Don't worry, we don't have to use this formula that many of times. We usually use the concept of 1 onto together to get this result also. Okay. Number of bijections is given as n factorial. This is very important. This is very commonly used. So this one and the first one is very commonly used. Okay. First one, even this also used sometimes, but first one and this the last one is very commonly used for number of functions. Number of bijections is usually asked in the examinations. Okay, so this is end of your chapter, relation and function. Do not worry, not the end when I say end of the entire chapter, only concept part. We'll have more clarity when you go and solve questions. I believe in applied understanding. And how you get applied understanding in mathematics? By solving problems, by doing the practice. So you come back for the question session and there you will understand all the concepts very clearly with the help of problems. Now time to learn ITF, inverse trigonometric functions. We have learned trigonometric functions, remember? They're total of 6: sine, cos, tan, cot, sec and cosec. Inverse of a function is what? Invertible function. What happens there? If you can say the function is 1 and onto. If the function is 1 1 and on 2 means basically bijective, then the function can be taken as inverse. You can find the inverse of the function. It's called as invertible function. Okay, then it is called as invertible function. And what happens there? Your domain and range interchange. Your domain becomes range and the range becomes equal to domain. Okay, so domain becomes equal to range and range becomes equal to domain in the case of if you're looking to find the inverse of a function. Okay, so same thing in the case of sine, cos, tan, whatever is the domain, if I take sine inverse, domain and range will basically swap each other. Okay, they'll just interchange each other. Alright, domain range of ITF. Now think about it. Actually, if you look at the graph of sin x, this is the graph of sin x. So is this 1 1 function? Draw a line. You will get more than 1 intersections. It means not 1 1. So what happens now in this case? Directly the trigonometric functions are not invertible. So we have to make some changes in the domain to make it invertible in nature. So we'll look into that. But right now understand something. So whatever is the changes made, once you get that, so your domain, the domain of inverse functions, okay, and we have something called as restricted domain. We'll learn about this right now. Don't worry, we'll learn about this right now, because what happens, so if you see the graph over here, this has more than 1 intersection. So of course for the entire domain of sin x, what is domain of sin x? Y equal to sin x. Domain is what? The domain is all real numbers. Means we can go from negative infinity to positive infinity. We can take any real number and the range value is what? Your range value is -1 to 1. So of course right now it is not invertible because it is not 1 1 in nature. It is not 1 1 in nature. But after making some changes, after making some restriction on the domain, we get to have our invertible function. We get to make the y equal to sin x as invertible. We'll see that case, don't worry. Okay, and this value, this is called as, this restricted domain of trigonometric function is basically becoming principal value branch of the inverse trigonometric function. I'll repeat myself. First of all, we cannot find inverse of any of the trigonometric function without making any restriction to the domain. Okay, now so we'll do something called as, which is restriction of a domain of trigonometric function. Once you do that, once you get the restricted domain, now that domain becomes the principal value branch, something called as principal value branch for ITFs, for the inverse of the trigonometric function. Okay, so that is very important. You'll see that, don't worry, no need to confuse you, you'll see that over here. Let's learn about restricted domain of trigonometric function. As I said right now, sin x is not invertible like this. Okay, but if I make a restriction, now for restriction we have one necessary condition. You cannot restrict anywhere. Okay, so restriction is made without change in range, without change in range. So you cannot change the range value, and then if you want you can restrict the domain. What's the range in y equal to sin x? The range value is given by -1 to 1, both closed. So domain will be in such a way that the range remains same. So of course we can see over here, this value over here will be your final curve, which will be invertible in nature, and domain will be now changed to, this value is -π/2 and this value is π/2. So now your new domain, or something called as restricted domain, is what? -π/2 to π/2. They're both closed, guys. They're both closed because we have to take the range same. This is a restricted domain and your range, if you check, is the same as -1 to 1. This is your -1 value and this is your 1 value. So this is the actual curve of y equal to sin x, which is invertible in nature. This is invertible. This is invertible because this is bijective in nature. If you draw a line like this anywhere, you will have only one intersection and range is this. So this is a invertible sin x curve. This is a non-invertible sin x curve. Okay, so right now we have applied the restriction. Understanding that restriction is done without making any change in the range. Range remains same. Please check. Here domain was all real. Here domain is restricted to minus pi by 2 to pi by 2. Now I told you something about principal value branch. Principal, okay, value branch. Now, what's the meaning of this? Any value lying in between for this, for sine inverse. If I write the function over here, sine inverse of x. What's the domain now? Please check for this. Domain of this will be the range of this. So domain will be -1 to 1. And what is the range? Your range in the case of sine inverse will be what? That restricted domain. The restricted domain of your sine x will become your range of sine inverse of x. The graph we'll see later. Don't worry about that. Right now you understand the domain and range. Range becomes domain and this restricted domain becomes your range. So basically the result of inverse trigonometric function is always an angle. If you solve a trigonometric function, basically equation, you'll get the answer as always an angle. Okay, it will be always an angle. Alright, that's why the principal value branch will always be the restricted domain. The principal value branch of inverse trigonometric function is the restricted domain. I wanted to explain you the statement. Is it done? Now I'm going to move on and show you how you make the graph. So similarly you end up with what you call the domain and range of all the functions. Check here. Domain and range of all the functions. For inverse, this is the domain, this is the range. Cosec inverse, this is the domain, range, and so on. You have to remember these, bacha. You have to remember all the 6 domain and range. They are very, very important. Now we'll see how we solve the graphical part. How we draw the graph. So basically inverse of any function, what happens is the image of the function about the line y equal to x. So if I have to draw the curve right now, this was the curve, right? This was the curve, y equal to sin x, this is the curve. And if you draw this line, okay, if you draw this line, actually it will come like this. It's not accurate. I'll draw the line first. This is your line y equal to x line. The curve is like this over here. This is your curve y equal to sin x. Sin inverse will be this. This is sin inverse. This is your sin inverse. Please check. So this green, this represents your y equal to sin x, and this represents your y equal to sin inverse of x. So y equal to sin inverse of x is the mirror image of the curve y equal to sin x about the line y equal to x. If I draw the graph finally, your graph looks like this. Okay, this point is what? This point is output, right? So you'll have pi by 2 and you'll have over here minus pi by 2, and this will be what? This will be -1 and this will be +1. This will be +1. This is the curve y equal to sin inverse of x. Please check. Here, domain and range, this is pi by 2, this is minus pi by 2, this is 1 and -1. So if you take the mirror image of the invertible function of trigonometric kind, okay, then that becomes your inverse of trigonometric function, sine inverse, cos inverse, tan inverse, all of that. I've taken example of y equal to sine inverse. How do we obtain the graph? Got it? Okay, so likewise we have other curves as well. Have a look. This is for cos inverse. Again the graph is, this is pi, this is 0, this value is -1 to 1. -1 to 1 is your What is this? Minus 1 to 1 is your domain, range is 0 to pi. This is the graph of tan inverse. So most of the time you will be using the graph which is given here as top 3. You will be using the first, second and third graph. You will not use many of the other graphs. This one and this one is the most important 3 graphs. Sine inverse, cos inverse and tan inverse are the most important 3 graphs. For these 3 you have to remember the domain and range, that's more than sufficient. Even for KCET also, for the last 3 graph, only domain and range is important. Okay, let's look at the K-hub now. Whenever no branch of inverse trigonometric function is given, we mean the principal value branch. Let's say sometime in questions they have not given any value of the branch from where to where, okay, then it means always about principal value branch, means the range which is coming out you have to write in the principal value branch, right? If you solve the function, right, if you solve this question, let's say, and you're getting the value of this will be a theta, right, y will be an angle, no, so you have to write this in the principal value branch of this. Whatever answer you get, you have to write in this format to get the answer in the principal value branch. Okay, the value of the inverse trigonometric function which lies in the range of principal value branch is called as principal value of the inverse trigonometric function. Very simple things, not difficult at all. Okay, so I hope this is very much clear, the concept of drawing the graph, domain and range, restriction of domain, and all these tables over here for the figure, for the graph and for the domain and range. That is all that you need to know from the concept side of the chapter ITF. Again, after this the properties parts are there. What is the property in the principal value branch? Okay, what happens here? Sine inverse of sine is going to be x, cos inverse of cos is going to be x, tan of tan is going to be x, and likewise. Okay, we also have some very important properties I want to mention. Sine inverse of minus x is going to be what? Minus sine inverse of x, minus sine inverse of x. Okay, so this will be same for cosec inverse also. Very useful in the questions, guys. For cos it will be what? Something different. For cos inverse it will be pi minus cos inverse of x. Again, there are proof for all these properties. You have derivations for all of this, but not required right now. Exam point of view, just the property is good enough. Okay, again this is going to be same for cot. We'll have this same for cot, and for tan it will be the same as sine minus tan inverse of x. For cot it will be same as cos, okay, but for tan it will be same as sine inverse. So basically over here this one and this one is very important, even this one. These 4 are the most important 4 properties involving inverse when the angle is negative inside. Sorry, when the value is negative inside, then the angle is dealt like this. Pi minus cos inverse over here, same in the case of cot inverse also. Please check. Sec inverse will also be same as cos inverse. Okay, this will be also same as cos inverse. Got it? This is clear, guys. So this completes our chapter, all the concepts in the ITF and relation and function. I have tried to explain you whatever it's important for you. If I have missed something, you can let me know. When I come for the marathons, I'll explain you all the concept that has been missed. So please understand this very clearly. I've been getting your your comments. This chapter is not there, sir. This chapter is there in my syllabus, sir. Something additional. Don't worry, I'm keeping a note of all of this. When I come for marathon, I will do those chapters. So do trust me when I say I promise that I'm gonna make a complete effort to to get you out of marks in boards, in your midterms. Then I'm gonna make that effort. So whatever chapters that you said, even one student said that sir, vectors is coming. Do not worry. I'll take some questions of vectors also and explain it to you in the marathon. Even it's not required because most of the colleges don't have vectors in their syllabus. But even if it is there for one student, I'll try to make that. I'll try to incorporate the questions part at least in my, if not concept, at least I'll solve the questions and explain you the concept with the help of the questions. That's a promise. So don't worry, I'm here. Whatever is your concern, leave that with me in the comment section. Something I missed, it's okay. Leave that with me in the comment section, and I'm going to incorporate all of that in your marathons. That's a promise. So with this, I can end the session right now. For all of you who joined for the first time, please don't forget to subscribe to the channel. It's very important for all of us working here at Diksha Karnataka to provide you the content that you need to ace your examination. It gives us energy, the motivations to come here and deliver better and better sessions. Right now, I'm going to take your permission, take your leave. I'll come back again very soon. Till then, take care. Bye-bye.